If you're looking to sell your house in Connecticut and want to gain a general idea of its market price, then this is the website for you. This is the Connecticut Property Price Calculator. Let's begin. About the program. Using a machine learning regression model, our program is trained on vast libraries of property data and compares the information entered by the user to existing house sales prices. Through doing this, it is able to get an accurate general idea of what your house is probably worth on the market. This helps relieve stress of the person selling it, as they can know whether it's a good time for them to sell or not based on what it gives. If the price is lower than they expected, they might want to hold off on selling. The module's labels, meaning the variable of interest, is the house's market price. The label is found throughout the model analyzing the features. Square footage of the house. The features are square footage of the house, square footage of the land, city, number of bedrooms, number of bathrooms. The user will be asked to enter each one of these. Explanatory data analysis, or the EDA. The graph shows all the variables and their degrees of influence on the value of the houses in Connecticut. From the chart, we gathered that the zip code had the most negligible effect and that the number of beds and bathrooms had a significant impact. To further analyze our results, we graphed each feature separately. It showed a strong correlation between the number of beds, baths, prices. So we considered that when building our learning model. We graphed the label price as y-axis in all of our graphs, and the feature focused on as the x-axis. As you can see here, the price, as we compare the price number of beds, it has a significant correlation between the number of bedrooms and the price of the house. Thus, our model will prioritize this factor when labeling them, but will disregard other factors such as zip code and previously sold date and status, as those do have a negligible impact and are not taken into consideration. Thus, they would only slow our program down. We words. We hypothesized that the city would have the most significant impact on the price of the graph. The graph proves this to be accurate, as the lot size of the house is shown to be relatively the same at the same time. The city, designated by the color of the plots, changes as you go up the y-axis, exemplifying how the town will be the most impactful to the program and should be the primary feature examined by the learning module.
For our house predictor program, we use 3 different types of machine learning models, and it's all based off the data set we got from Kaggle. So of the 3, the first type of learning model we used was linear regression. And what linear regression does pretty much is plot out like all the different points of data on a graph, and it just like draws a line of best fit between them and uses that line of best fit to predict the prices based on like the based off the x-axis. For our second one that we used was the neural network machine learning model, which pretty much it has an input and an output, and then these are like nodes, and then these are also nodes, and then they like talk to each other to find out like which one's the best way of doing something, and eventually they combine with each other to create one output. And then for k-nearest neighbors, it's pretty much just based on whatever it's close to, because like it's based off separation pretty much. And the program's function is pretty much to find the price of a house using regression model, and then I also used grid search CV to find the most optimal parameters for each regression model. So the linear regression model was off by around $250,000 when it's trying to estimate the price. The neural network model was off by $165,000, and the k-nearest neighbors model was off by $135,000. And we'll head to this demo. Oh shoot. Give me a second. I don't know what's wrong with this. Okay, so apparently our demo's not working right now, so yeah, sorry. And it was made by me and Sarah.
See if it
Right,
works.
okay, now it works. So pretty much you could choose like the three different types of models. K nearest neighbors is our most accurate, so we'll go with that one. You could choose whichever city you live in Connecticut. I'll just choose a random one. You could put in the info of your house, like 2 beds, 2 baths, 1,000 square feet, and then 2,000 square feet lot size. And then if you click submit, it'll estimate a price of the price of your house for you. Yeah.